We're still working with polynomials, and this whole section is basically working with polynomials. We talked about how to graph polynomial functions, how to find the x-intercepts or the roots or what have you. Today what we're talking about is how to divide with polynomials. You learned back in Algebra 1 how to add, subtract, and multiply polynomials. Adding and subtracting, you just combine the like terms. Multiplying is where you distribute the pieces out, like foiling it out or whatever. And that's how you work with polynomials operations, but we haven't talked about division with polynomials. And that's what today's lesson is about. And there's two different methods that we're going to talk about during this lesson. The first one is long division. As the name suggests, it's a little longer. It's not the shortcut. We're going to look at the shortcut in just a moment. But with long division, it's very simple. Now, before we actually get to the long division, though, they did show you this one problem that is completely different than all the other problems in the lesson. And here's why. Notice I got a polynomial on top. It has three different terms, but the denominator does not have a plus sign or minus sign. If the denominator doesn't have a plus sign or minus sign, then you're going to divide this term into each one of those terms, and then you're done. It's that straightforward. So you would say 4 divided by 2, and when you're dividing by variables and their exponents, you just subtract their exponents. That's an understood 1 with the x, so it's going to be 3 minus 1, that'd be x squared. Y to the fourth over y to the second is y to the second. Then you're going to do the same thing to the next term. You say 6 divided by 2 is going to be a positive 3. X squared over x to the first is x to the first. Y to the fifth over y to the second is y to the third. And then again, do it to the last one where it's negative 6 x squared y. And this is your answer. If there's no plus sign or a minus sign in what you're dividing by, it's very straightforward. You just divide it into each one of the pieces and move on. But as you could probably imagine, that is not what the lesson's going to have you do. The lesson's going to have things like this where you have plus signs or minus signs in that parentheses that you're dividing by. And in order to do that, you're going to take what you're dividing by and put it out in front of the division bar. And what you're dividing into goes underneath. All right, so that's how you'll set this problem up. Now I want to remind you from 3rd grade how to divide with just regular numbers. If I were to divide 21 into 8,932, you would ask yourself, what do you multiply by 21 to get you close but not over 89? And that would be 4. 4 times that is going to be 84. Subtract those numbers. It's a 5, and bring down the next number. Then what do you multiply by 21 to get you close but not over 53? That would be 2, because that is 42. Subtract that, that gives you 12. Yeah, you bring down that 2 there. And then what do you multiply by 21 to get you close but not over 12? Well, nothing, right? So that would be a 0, and you subtract, and your remainder is 12. And then to write your final answer, you would write it as 420 and 12 over 21, which you could actually reduce 12 over 21. I know you can. I'm not worried about doing something simple like that right now. I'm just reminding you how to do the division with numbers, because the same things happen when you're doing long division with polynomials. Here's what I mean. You're going to ask, what do you multiply by the first term to get you the first term? You don't care about the minus 1 or the 4x. They're just going to happen. Okay, you're going to take care of things, but you're not going to ask questions about them. You're going to simply say, what do I multiply by x to give me x squared? And that would be x. Then you got to multiply x times both of these, the x and the minus 1. What's x times x? It's x squared. X times a negative 1 is a negative 1x. But just like in division a while ago, once you got your number there, you subtract it. So I've got to subtract both of those things. Those cancel out, and they always should, or else you didn't do that part right. But what is 4x minus a negative 1x? Well, that's the same thing as 4 plus 1, which is 5x. Bring down the next term. Then start the process over. What do you multiply by x to give you 5x? That'd be a positive 5. Make sure you separate that with a plus sign because we're dealing with polynomials. That'd be 5 times x is 5x. 5 times a negative 1 is a negative 5. Don't forget you're subtracting this whole thing off. Those go away, so do those. That gives you 0 as a remainder. That means that my answer is x plus 5. Got it? Notice because I had a 0 as a remainder, I didn't have to do anything with that remainder. We'll look at several problems here in just a moment that do have a remainder. Now, if you'll notice this problem, it's written a little weird. It's got a -1 as an exponent, but notice if that's not there, this is a multiplication problem, isn't it? This -1 is pretty important simply because that's what tells me that I'm actually dividing this by that. Remember, negative exponents tell you to flip the fractions, so it would be this first thing over this second one. And that's the division part of it. I do not do anything with the -1 though. I don't distribute the -1. I don't change any signs. I don't do anything weird with it. All I do is just know that's telling me to divide this polynomial into this polynomial. So to set it up, I'm just going to simply do x plus 2 divided into all of this. This is just the algebraic way of saying to divide. Whereas the problem we saw before with that division sign, that thing looks like that, a little dash with the 2 dots, that is the arithmetic. That's arithmetic. That's an arithmetic symbol. This is the algebra way of saying to divide. Okay? They mean the exact same things. So your process is very straightforward. What do you multiply by x to give you x to the third? Be x squared. So multiply x squared times both of these. That gives you x to the third plus 2x squared. You're going to subtract that thing. Those go away. -3 minus 2 is a -5x squared. Bring down the next term. So what do you multiply by x to give you a -5x squared? Well, it'd be a -5 and x. So -5x times x plus 2, you can say that times there, it gives you -5x squared. -5x plus 2, or times 2, is a -10x. Don't forget you're subtracting. Those go away. 4 minus -10 is 14x. Bring down your next term. Then ask again, what do you multiply by the first term to make that the first term? What do you multiply by x to make it 14x? Be a positive 14. So that'd be 14x. 14 times 2 is 28. Don't forget you're subtracting. Those go away. What is 6 minus 28? It's a -22. So to write your answer, it'd be all of this. It'd be x squared minus 5x plus 14. And then you always put your remainder over what you're dividing by. Just like we did with numbers, you put your remainder over what you were dividing by. Now, I could have just put, instead of having the negative up top and having the plus sign there, I could have put the minus sign right there and been done with it. Either one of those is correct, but you can't not have something there. These are polynomials. You have to have either a plus sign or minus sign between the fraction and the term in front of it. Okay? So that is how you write that answer. This is the part where I would ask if there's any questions, but we're not in an actual classroom, so you'll just have to pause and send me your questions if you have any. Might be better if you just wait and keep watching, take notes, re-watch that problem, see if it answers the question that you're asking for. So again, what part of this problem shows me that this is division? It's that -1 is an exponent right there. Now, the one thing that you got to watch for on these types of problems is you do have to watch for if there are terms missing. Here's what I mean by that. You've got an x to the fourth, an x to the third. You don't have an x to the second power. So when you're setting this problem up, you've got to account for each power in order. So there's x to the fourth, 5x to the third. I don't have an x to the second, so I need to put that 0x squared in there. Minus 8x plus 10, and then put the x plus 1. you have to have all the powers accounted for in the problem into what you're dividing into or what you're dividing by if you're missing a power over there as well. So then multiply. What do you multiply by x to give you x to the fourth? That'd be x to the third. Multiply x to the third times both of those. That'd be x to the fourth plus 1x to the third. You're subtracting these things off. Those go away. 5 minus 1 is 4x to the third. Bring down your next term and do it again. What do you multiply by x to make it 4x to the third? That'd be 4x squared. What's 4x squared times each of those? That'd be 4x to the third plus 4x squared. You are subtracting these things. Those go away. What's 0 minus 4? It's a negative 4x squared. Bring down the next term. Go through the process again to get x to become negative 4x squared. That'd be a negative 4x. Multiply it times both of these things in the front. Gives you a negative 4x squared and a negative 4x. Don't forget you're subtracting those off. Those go away. What's negative 8 minus a negative is a plus sign. So that's negative 8 plus 4. That'd be a negative 4x plus 10. One last time. What do you multiply by x to make it a negative 4x? That'd be a minus 4. So that'd be negative 4x minus 4. Don't forget you're subtracting. Those go away. 10 minus a negative, that's a plus sign. 10 plus 4 is 14. So there's my remainder. So for my remainder, I can just stick it on the end of there and put it over what I was dividing by. This is my answer. Does that make sense? As if I'm going to hear you say no. If you say no. Now it turns out that the lessons, today's lesson, this lesson that we're going through right now is super easy once you get the hang of it. Once you learn how to set these things up and get these things knocked out, you can roll through these pretty easily. So here's the next problem. I've already done the setup for us. I've already got the 2x plus 3 that you're dividing by up front. I've already got the thing you're dividing into under the division bar. We're still going to ask the same questions. What do you multiply by 2x to make it 2x to the third? Well, it needs an x squared. So that'd be 2x to the third plus 3x squared. Subtract those off. Those go away. What's 11 minus 3? It's going to be 8x squared. Bring down the next term. What do you multiply by 2x to make it 8x squared? Well, 2 times 4 would give me the 8, but I also need to multiply by an x. So it's going to be 8x squared plus 12x. We're going to subtract those. Those go away. What's 18 minus 12? That'd be 6x. And what do you multiply by 2x to make 6x? It'd be a positive 3. So 3 times both of those would be 6x plus 9. Subtracting these off gives you 0 as a remainder. Now, when I get 0 as a remainder, what that tells me is, first of all, this is my answer. You understand that. I don't have to write a remainder if the 0 is a remainder. It's just x squared plus 4x plus 3. And because 0 is the remainder, that means 2x plus 3 times x squared plus 4x plus 3 would give me this big long thing, which means these two things are both roots of this. I could get 2x plus 3 is one of the roots, and that's a root, and we'll talk about that later. But having a 0 as a remainder means that it went evenly, which means it was one of the factors of that original problem. Okay? So that's how simple long division is. Another way that they might write these problems is to actually have them listed one on top of the other, because that's what the negative 1 exponent tells you to do anyway. It tells you to put one on top of the other, but it's still division, all right? So the thing that's on top goes inside the house, the thing that's underneath goes out front. This one has 3 terms in it, in what you're dividing by. Still going to use the same process, okay? You're going to say, what do you multiply by x squared to make it x to the fourth? That'd be x squared. You got to multiply x squared times all three of those and line them up here. X squared times x squared is x to the fourth. X squared times negative 3 is negative 3x to the third. And negative 1 times x squared is a negative 1x squared. You're now going to subtract those. Those go away. What's 1x to the third minus a negative? Minus a negative is a plus sign, right? So that would be 1 plus 4 x to the third. And then negative 17 minus a negative. That's a plus sign as well. So it's negative 17 plus 1 is negative 16 x squared. Bring down the next term and go again. What do you multiply by x squared to make it 4x to the third? You need a 4 and another x. So that'd be 4x to the third. Multiply those together. That gives you a negative 12x squared. Multiply those together gives you negative 4x. Those go away. What's negative 16 plus 12? 11 plus 4. Bring down the next term. You got one more time to go with this. What do you multiply by x squared to give you negative 4x squared? Multiply those out. You get negative 4x squared. Positive 12x. Positive 4. You're subtracting these things off. Those go away. 15 minus 12 is 3x. 5 minus 4 is 1. So this time I ended up with a remainder that has a plus sign or minus sign, but that does not change how I write the answer. My answer is x squared plus 4x minus 4 plus my remainder over what I was dividing by. This is my answer. You doing good so far? All right. One of the most missed problems on the test or quiz is something like this. And it's not because it's difficult, it's because you're going to forget very simple steps. When I'm setting up this problem, it's long division. Remember, I have to account for every power from the highest down to the 0 as an exponent for both the top and the bottom. So inside the house, I'm going to have x to the fourth. I'm missing the x to the third. Minus 4x squared plus x plus 5. On the division, what I'm dividing by, I have x squared. I don't have an x minus 1. I have to put the 0 on this stuff as well to hold places for those. All right. So, what do you multiply by x squared to give you x to the fourth? Bx squared. Multiply x squared times all three of those. Bx to the fourth, 0x to the third, minus 1x squared. And we're subtracting. Those are going to go away. So are those. So I'm left with negative 4 minus a negative 1. Minus a negative is a plus. It's negative 4 plus 1 is a negative 3x squared. Now, since I lost both of these, since I lost 2, I'm not just bringing down one term, I'm going to bring them both down. What do you multiply by x squared to give you negative 3x squared? Be a negative 3. That'd be negative 3x squared plus 0x plus 3. Now subtract those. That goes away. 1 minus 0 is 1x. 5 minus 3 is 2. So that's going to be my remainder. So my answer is x squared minus 3 plus my remainder over what I was dividing by. Doing good? And we got one more problem. Deals with imaginary numbers that the book says. It says to divide this by that. Okay, if I'm going to divide into there, I know I'm going to have an x to the fourth. I'm missing an x to the third. I'm missing an x to the second. Oops. I'm missing an x, and then the constant is 1. And I'm dividing by x squared. I'm missing the x, and I is going to work as my constant on this one because it doesn't have an x. So what do you multiply by x squared to get x to the fourth? The x squared. Multiply x squared times all three of those. It gives you x to the fourth, 0x to the third, plus I, x to the second. You are subtracting these things. Those go away. So do those. And this is going to be 0 minus I. Well, 0 minus anything is just a negative of those things with an x squared. Let's bring down the next two terms because like on the last problem, we lost these first two, so we need to bring down the next two. And you ask, what do you multiply x squared to give you negative I x squared? That'd be a negative I. So multiply negative I times all three of those. Negative I times x squared is negative I x squared. 0 times anything is going to be 0. And negative I times I is negative I squared. Now when I go through to subtract these things off, those are going to go away and those are going to go away. But I've got 1, I'll do that right over here, 1 minus I squared. Now what do we know about I squared? Oh, excuse me, that's 1 minus a negative. That's 1 plus I squared. Sorry, that minus a negative makes that a plus. What do we know about I squared? We know anytime we see I squared, we can replace that with a negative 1. But what's 1 plus a negative 1? That's 0 also. That was 0, that's 0, and that's 0. That means our remainder is 0. So the answer to this division problem is just x squared minus I. Okay? All right. So the next problem is going to, or the next section is going to be synthetic division. That's what your next part of this